Let's say that we're given this reaction and we're asked to find the standard cell potential. We can do that by using our standard reduction potentials. So if we look at this first half reaction, we see that silver ion, if you add an electron to silver ion, you get solid silver. So gain of electrons is reduction. So this is a reduction half reaction. If we look at the reaction on the right, we can see that we are reducing silver ion. So here's silver ion, which is being reduced to solid silver. So we need this half reaction as it's written. So this is going to be our reduction half reaction. So we have Ag plus, plus an electron, right, giving us a solid silver here. The standard reduction potential for this half reaction is positive 0.8 volts, right? So this is positive 0.8 volts. Next, let's look at what else is happening. We're turning solid zinc into zinc 2 plus ions. How do you turn solid zinc into zinc 2 plus? Solid zinc would need to lose 2 electrons to turn into zinc 2 plus. Loss of electrons is oxidation. So if we go over here to this half reaction, all right, we can see that this half reaction is written as a reduction half reaction. Zinc 2 plus is being reduced, it's gaining 2 electrons to turn into solid zinc. We need to write this as an oxidation half reaction. So it's given to us as a reduction. We need to write it as an oxidation half reaction. We simply need to reverse it. So we need to start with solid zinc. So we start with solid zinc here. And for solid zinc to turn into zinc 2 plus ions, we need to lose 2 electrons. So loss of electrons is oxidation. So we need to find the standard oxidation potential next. And we can do that by looking at our table once again. The standard reduction potential for this half reaction as it's written is negative 0.76 volts. Since we reversed this half reaction, right, we need to change the sign from negative to positive. So for the reduction potential, it's negative 0.76. For the oxidation potential, it's positive 0.76. So the standard oxidation potential for this half reaction is positive 0.76 volts. Next, we need to look at moles. So if we look at our reaction, we have 2 moles of silver ions being reduced to 2 moles of solid silver. Down here we have 1 mole of silver ions being reduced to 1 mole of solid silver. So we need to multiply everything by 2 here. So we get 2 moles of silver ions, which require 2 moles of electrons to turn into 2 moles of solid silver. Now, it might be really tempting to say, oh, well then don't we just multiply our reduction potential by 2 as well? And we don't, for the reason that we talked about in the previous video. Voltage is an intensive property, so it doesn't matter if you're forming 1 mole of silver or 2 moles of silver, the voltage is the same. So we're going to leave the voltage at 0.8 volts. All right, next, we have the number of electrons equal, so we can add our 2 half reactions together to get our overall reaction. So if you add the reduction half reaction and the oxidation half reaction, together we get our overall reaction. So the electrons lost by zinc, these 2 electrons here, are the same electrons that are gained by the silver ions. So those cancel out. And on the left side, we would have 2Ag plus solid zinc. So let's write that in here, 2Ag plus solid zinc. And for our products, so over here on the right, we have 2Ag plus zinc 2 plus. So we have 2Ag plus zinc 2 plus. Notice this is our reaction, right? So if I box this here, this overall reaction that we've just found is the same as what we were given in our problem, right? So we found our overall reaction. But remember, they wanted us to find the standard cell potential. So how do we find the standard cell potential? We talked about how to do this in an earlier video. To find the standard cell potential, right, you can think about how we found the overall reaction. We added the reduction half reaction and the oxidation half reaction together to get the overall reaction. So to find the standard cell potential, we need to add the standard reduction potential and the standard oxidation potential together. So if we add the standard reduction potential and the standard oxidation potential together, we should get the standard potential for the cell. So let's go ahead and do that. The standard cell potential is equal to, this would be positive 0.8 volts, so positive 0.8 volts plus positive 0.76 volts, plus positive 0.76 volts, which is equal to positive 1.56 volts. So the standard cell potential is positive 1.56 volts. Remember, a positive value for your potential means a spontaneous reaction. So this is how to use your reduction potentials to figure out a standard cell potential.